Alright, I'm going to try to do the lawnmower problem again, because I think it's very difficult, very important that we know how to do it. So the question says we have a lawnmower. I'm going to represent it by that dot. Right? There's a push. And I call that push F of H. Right? With an angle above the horizontal called theta. Alright? So that's the lawnmower. The questions ask what is F of H if we want the lawnmower to move at a constant speed. Alright? Now, as soon as we hear constant speed, acceleration equals 0 should be the first thing we think of. Alright, so let's draw our force diagram or our free body diagram. So we have a lawnmower there. The first thing I draw is weight, right, which is mg. In this problem they want to leave weight, so let's leave weight alone and not put mg. Obviously there's a normal force and there's the force, which I'm gonna draw what red in a green vector in that direction with angle theta. Right, now I'm gonna decompose this F of H, right, with F of H cosine of theta, and this one right here will be F of H sine of theta. Now there's obviously friction in that direction. Let's call that friction F. Okay, now let's draw our sum forces in the y direction, and let's take positive to go up and positive to go that way too. So this is the y, this is the x. So normal minus weight minus FH sine of theta. Right? Let me rewrite that a little bigger so that you can see. Normal minus weight minus F of H sine theta equals 0. Okay? Now I'm going to put normal. I'm going to solve this equation in terms of normal and put everything on the other side. Okay? So that's my vertical forces. I'm going to do the same thing. Let's call this 1 here. I'm going to do the same thing in this direction, the horizontal direction. This direction I only have two forces. I call it F because this is the force in that direction. I call that positive right here. So I'm going to subtract it by F of H cosine of theta. And that has to equal 0 since our lawnmower is moving at a constant speed. Acceleration has to be 0. Right? So I'm also going to put F of H on the other side in this case. Okay? So now I'm going to try to solve this normal force. And I know this normal force is the same thing as the weight plus the F of H sine of theta. Right? So another thing I could do is my friction is always my mu times my normal. Okay? So I'm gonna put this normal inside here so that my F prime will be mu times W plus F of H sine of theta. Okay? So now since F equals that, I'm just gonna put this in there, right? And if I keep writing down, you won't be able to see, so I'm gonna just skip to the next page. So now I have F equals FH cosine of theta, but I just figured out that F was mu W plus F of H sine of theta. Alright, so I'm going to plug this right there. Mu W plus F of H sine of theta equals F of H cosine of theta. Okay, so I'm going to distribute my mu, so I could have mu W plus mu F of H sine of theta equals F of H cosine theta. I'm going to put my F of H's to the other side, so I could have mu W equal F of H cosine theta minus mu F of H sine theta. Now from here I could pull out F of H and divide by whatever is left inside, and that's how I get my answer. Alright, all done. It's a fairly difficult problem, but it's a good problem since we have all the forces taken into consideration, and we don't have any numbers that they gave us, so it's pretty good in terms of being able to solve general problems. And I hope you understand it.